కంప్యూటర్ ఆడియో వస్తుందండి. మనది కెన్ యూ ప్లీజ్ యాడ్ మై ప్రెజెంటేషన్ టు దిస్ శ్రీనివాస్ గారు? హలో, ఆడియో రావట్లేదండి.
Sir, it is audible, sir. It is audible. It is voice is clear.
Yeah.
At the bottom, you will have a share screen. In that,
No,
you have.
Yeah. Unfortunately, I am not at my office. Dr. Srinivas will share the screen.
Sir, I will tell you, sir. Just 1 minute, sir.
Shall I share the screen, sir?
Yes, Shweta madam, please.
Madam, Shweta madam, just when I tell you, then madam, just wait.
Okay, sir. Okay, sir.
After my instruction, you share the PPTs.
Okay, sir. Then.
1 minute.
ఒకసారి గూగుల్ డౌన్లోడ్ చేసి డిస్ట్రిక్ట్ వస్తుంది.
Good afternoon, Ishwarya, sir.
Not really.
Good afternoon, Director, sir. Director, sir, not yet joined, madam. Just 1 minute, sir. After joining Director, sir, I will start session. Okay, sir. Otherwise, already it is program is delayed, sir. So let us start, sir. So sorry for the inconvenience. It is delayed by 20 minutes.
Yeah.
So 1 minute, sir. We'll introduce you, sir, first. Then we will start the session, sir.
Yeah. Okay.
Yeah.
Are you able to see the presentation there now, Srinivas garu?
No, sir.
Okay.
We will share it, sir. After the introduction, we will share the presentation, sir.
Okay. Right.
Okay, sir. Okay. Good afternoon to one and all. A warm welcome to 4th day session of this online 1-week faculty development program on advancements in construction materials and practices. Now I take a privilege to welcome today's speaker, respected Dr. Sheila Ishwaraya, sir. He is going to explain the significance of green building design. Before start the session, I request Mrs. G. Shweta madam, Assistant Professor Civil Engineering, to introduce the speaker. All the very best to all of you and happy learning.
Thank you, sir. Good afternoon, one and all. It's a great pleasure for me to introduce today's speaker, Dr. Sheila Ishwaraya garu. He is presently worked as Chief Engineer in Telangana Rajiv Sagruha Corporated Limited. He did his PhD in Civil Engineering, JNTU Hyderabad. Prior to this, he completed MTech in Environmental Engineering, NBA in Operational Management, BTech in Civil Engineering, PG Diploma in Urban Planning and Development, PG in Alternative Dispute Resolution, and PG Diploma in Environmental Law. He has vast experience of 37 years in planning execution of affordable housing schemes with focusing on cost-effective construction technologies. He worked in a combined state of Andhra Pradesh and in newly formed state of Telangana in different cadres and has chief engineering heading the state. He is a fellowship member in Institute of Engineers, India. He and also a member of Indian Building Congress, New Delhi, and Committee of Rejuvenation of Building Center, Housing and Urban Development Corporation, MOUA, Government of India, Technical Committee for Codification of Rural Urban Technologies, MORD, Government of India, Indian Green Building Council, Hyderabad, and also member of Pre-Engineered Structures Society of India, Hyderabad. Thanking you, sir. Welcome to this session, sir.
Thank you.
Sir,
Thank
sir,
you,
are you sharing the PPT, sir, now?
just I want to see whether are you able to see my PPT?
No. Hello, sir.
1 second. I'm sharing it. Just click a double click.
Are you sharing through mobile, sir?
No, I'm sharing through the same laptop from which I'm doing.
Okay, okay.
Are you able to see this?
Yes, actually, we are able to see your all data in the mobile WhatsApp group.
Oh, you're
Your
seeing
WhatsApp group is visible, sir.
Okay.
Now your presentation is not visible.
So
to
we
us.
are. So that I think you're seeing the WhatsApp. So
Yes,
you
sir.
do one thing, sir. You share it, please.
Okay, okay, sir. You stop it, sir. You stop it, sir. We will share it.
Okay, then. Yeah.
Sweta, madam, please share the PPTs.
Okay, sir. Okay, sir. I will share.
Sir, please stop the screen sharing, sir.
Okay. Yeah. This has to be stopped, no?
Yeah. Stop sharing option is there, sir. Please stop that.
Okay.
Yes, sir.
This is being shared by you now.
Yes, sir. Yes, sir. Sweta, madam, enlarge this. Yeah.
Can you make full screen, Sweta Garu?
Sweta, madam, slideshow. We keep in slideshow. Hemalata, madam, you go and help her.
Okay. So, okay, it's all right. Sweta, I think Dr. Sweta will do that. Before that, let's get into the subject now.
Yes, sir.
We are talking about design of buildings. Basically, I think most of the faculty and the students here are from structural engineering. So my focus is something like design of buildings in the perspective of environmental design or sustainable design. So we will just go through issue one after the other. Can I see the sharing, please? Yeah. Next. So we can call this as environmental design of buildings or sustainable design of buildings, because we are not limiting to certain factors, but we'll get into so many other factors how a building should be designed. Next. Next. Am I audible, Srinivas Garu?
Yes, sir. Yes, sir. Your voice is very clear, sir. Sweta, madam, please go to next slide. Sir, 1 minute, sir. Due to some net issue or something, it is not changing the slide.
Yeah. See,
1 minute.
See, my presentation or my subject will be going with design of buildings with reference to environmental parameters, and we go with the two things. Why a green building? Why building should be designed green? Then we'll get into what are the components of green building. Then we discuss about what are the parameters that we look into for design of a green building. This is how we just proceed with our class. Next, madam. Yeah. So why do we need a green building? Because day by day we are urbanizing, and more than 50% of the buildings or the offices or the houses that were today are yet to be built. Actually, whatever the stock we are going to see in 2030, the present stock would be around 40% only. The next 60% is going to be added by 2030. And by 2050, the built-up area of India may be around 4 times the current mass. So this is a study made by the Ministry of Urban Development that indicates the demand of buildings and as well as the general requirements required for design of the building. This makes us to give a agenda, or that makes us to give an a template that how we should proceed further. Next. Next. So this construction, of course, is an essential part of development. We need construction for everything, for every infrastructure, buildings, what maybe factories or whatever. Construction increases the economy, it increases the employability, and it is required for the economic growth. And at the same time, construction also responsible for the consumption of huge energy. Similarly, it's a parallel thing that when you consume the energy, then you'll be emitting the emissions, also carbon emissions. So construction, it's a very big, as on one side, it's a growth engine. The other side, it is a very big pollutant. Like 30% of the raw material is used in the construction, then turned into a waste. Then it produces the waste. And construction consumes around 20% of the water resources. Whatever the water that we have, 20% of the water goes for the construction of these things. And we also consume a lot of land. Land is also, we treat land also a source of energy, and water is energy, raw material is energy, and basic building materials are also energy. So construction consumes a lot of things, and also they produce a lot of waste in that. So construction, this has to be kept in mind while designing the buildings. Next. Next. I think so. When we say that the building stock is going to mundu slide, building stock yeah, next. Building stock is going to be 4 times or more by 2050. Next. Yeah. Next. So we will find that more urbanization causes the urban heat island. This is an effect that we see in the urban areas, where the pavements, roofs, everything is either by concrete or by asphalt or by some other material. So there is a lot of heat that is produced, and there is a lot of emissivity between the different materials that buildings are constructed with, and there is lack of evapotranspiration also, because there is no vegetation. There is a lot of increase in the whole gets evaporated, and you will have loss of moisture in the atmosphere. It increases the heat, and that the whole area gets into like a heat island. This is a concept that huge urbanization will lead to an urban heat islands in the urban areas. Next. And as you see, even the buildings, if they are tall buildings, they provide multiple surfaces for the reflection and absorption of sunlight. They increase the efficiency which urban areas are heated. This is called the urban canyon effect also. What goes building block, they block wind, which also inhibits cooling by convection and prevents pollutants from the dissipating. Waste heat from automobiles, air conditioning industry, and all other sources also will add to the urban heat island. Next. High levels of pollution, of course, it also increases the UHI and all forms of pollution. Majorly, it's due to radioactive properties of in the atmosphere, and there is raise in the temperature, increase in the concentration of ozone. See, these are the few effects that of urban heat island. But now we can think of some mitigations. Some of the mitigations that can be done are by white roofs, green roofs, planting trees, or green plotting parking lots. But we as civil engineers will be concerned with white roofs and green roofs. Next. When we talk about construction and building activity and building materials, this building construction activity, every stage of activity has got some environmental effect, right from the mining of the material, maybe it's because of land erosion or water pollution or deforestation, or manufacturing of the material, a lot of energy is consumed in it, transportation of the material, energy is consumed in it, and building, it is exactly directly the building materials, and maintaining the building. You consume a lot of energy for air conditioning, for lifts, power, mechanical components and all that. Then demolition also. This is one area where the demolition wastage also should be taken into consideration while making a design. Then we have recycle waste also, like groundwater gets contaminated with the continuous building. Next. Then we think, what is a green building? This green building is the practice of increasing efficiency by which the buildings are by which building use resources, energy, water, and materials while reducing the building impacts on human health. We use minimum resources and reduce the impacts on the human health. They ensure that the waste is minimized at every stage during construction operation and entire life cycle cost of the building also. Throughout the life cycle, will ensure that the waste is minimized. Next. These are the small components which may, which is of course not required. The small elements where how do we add some things for making a building green? Something like shades, sun shades, green shades. You are adding a new renewable energy sources. Next. This is not an issue. These are, you know what are they? This is lighting, of course. This is reuse of water. This is using the reused water as a third pipeline. We generally use the gray water also for flushing the tanks. So we are reusing the water. Next. There are not required. Next. Some shading elements. Next. Next, this is not required. The green building, okay. There are the two different rating systems for greening in India. Generally, we go with that. The one is Griha, the other is LEED. LEED is generally now it is taken up by IGBC. We call IGBC rating and also Griha rating. They take so many parameters into consideration while rating a building. They take site planning, water management, waste management, health, well-being, building operation and maintenance, then energy and atmosphere. They take sustainable building materials. They use material inputs on all the parameters that you can see. Next. This is actually not that required. So it needs sustainability in design and construction. What we need is we need to have sustainability factor in design and as well also in construction. Next. And it is also a legal obligation on our part to see that these buildings are built green, because Environmental Protection Rules 2006 says they need to be have a environmental clearance. Buildings above 20,000 square meters or townships covering more than 50 hectares, they necessarily have to have an environmental clearance. So there is a legal obligation also on this part to design a building or to execute a building green. Next. Then how do we go with the sustainable construction? Then what is sustainable construction? Sustainable construction is using natural resources in such a way that they meet the economic, social, and cultural needs, but do not deplete or degrade the resources to the point that they cannot meet the needs of the future generation. So we must consume the needs within the available limits without foregoing the requirements of the future needs of the future generations. This is how we define the sustainable construction. Then we have different methods of constructions, generally traditional construction method, conventional construction method, and latest fast track construction method also we have. We have different materials, indigenous materials are there, locally produced materials are there, even the industrially produced materials are there. Screen percentage tagistara, madam? I think that is screen sharing low.
Sir?
Screen percentage of screen sharing. Okay. Okay. So next. So the UN also had got into that, and International Standards Organization has established some set of indicators for assessing the sustainability and performance of new or existing buildings. And they are with relation to the design, construction, operation, maintenance, refurbishment, and at the end of the life. All parameters have been, all at every stage of construction, there is a need for sustainability, and ISO 2021-929 has indicated, has come up with some 38 core indicators by which we can assess the performance of the building. Some of the factors are safety, functional performance, material use, power and water consumption for construction, then pollution drawing construction, operation and disposal of, including waste disposal, carbon footprint, thermal comfort, indoor air quality, maintainability, life cycle cost, impact on the economy, and like that. Next. Next. Then when we talk about sustainability, sustainability is dealt very thoroughly in part 11 of NBC now. I think everybody is conversant with this sustainability factor, and already you may be dealing with these things. Then sustainability is generally, it is suitable design, sustainable use of material and alternate material, optimizing building envelopes. This may be a little new one for you. And building services, optimizing building services, sustainable building services, water and waste management, of course, refurbishment and demolition. They also include the sustainability factors which are not dealt with the part 11 of NBC. They are like, but they are included in the old NBC. Architectural parts are there, like siting, built environment, landscaping, habitat planning, then lighting, fenestration, ventilation, services, functional performance. These are also other factors which are mostly dealt by the architects in designing a sustainable building. Next. Then generally, now the question is, what is sustainable design or what is environmental design? Generally, in civil engineering, we are taught in engineering colleges that the design means, structural design means it is to address the requirement required for failure. That is generally strength. What we do is we check for strength, and then we check for stiffness. Stiffness, then all dimensional stability checked, and we go for stiffness, and strength we do, and all other forces like bending, earthquake forces, or even temperature stresses. So basically, our activity in civil engineering or structural engineering have been limited to checking failure by fracture, or checking to dimensional stability or dimensional instability, resistance to deformation. Deformation may be either by sliding or by earthquake or by lateral forces, or due to bending, due to creep. These things are dealt in our system. Then we have some parameters of environmental issues which need to be now discussed, that can be included, added now, or durability. Of course, the service life of a material under given environmental condition, and sustainability. Durability is dealt by a code. Sustainability is not yet dealt by code. Sustainability is that you assess what is the consumption of resources in designing a building. What are the inputs that you are taking into your design? You take cement, steel, concrete. Majority of our structural design, we deal with only cement, sand, or fine aggregate, cement, fine aggregate, or steel. So these are only the two materials that generally we talk about. We should talk about all the material inputs and the energy required to bind them, build them, and the water required to bind them and build them. Next. For instance, when we talk about the general physical parameters of the building that we have, there are two parameters generally we look into. That is elastic modulus when we design, and then the density we take into consideration. You can see the timber, brick, concrete, RCC, steel, aluminum, how the strength varies, the elastic modulus and the density. What is the elastic modulus? That is very crucial in our design with reference to that density. We have other two parameters also which we can add in the design. That is the energy consumption and the carbon footprint. Consumption of carbon footprint that it is going to leave. every cubic meter of brick leaves around 706 kgs of carbon dioxide. So when you are taking these two parameters, elastic modulus and strength, and finally density and elastic modulus are taken into consideration to arrive at a required strength or to safeguard the required forces. So these two factors like energy and carbon are also need to be checked up to address the minimum consumption of energy and the least carbon footprint. Next. Next. No, yeah, material options also we have. For instance, you take materials. We will see how the energy consumption varies material to material, because all are civil engineering materials. We categorize all materials based on their energy consumption or embodied energy. We call high energy materials, very high energy materials, medium energy materials, low energy materials. Generally, we talk sand, aggregate, fly ash. These are all low energy materials. Medium energy materials are simply manufactured locally, like clay bricks, tiles, concrete, bricks, timber. These are all the locally manufactured or prepared materials. High energy materials are steel, glass, lead, cement, and then very high energy materials are aluminum, plastic, copper, stainless steel. See, you can see there is wide range of materials that are available that can be used for construction. It's not limited only to cement. It's not limited only to steel. We use every part of the material. Now we must know the embodied energy of each material to choose for our required strength. So when we are talking about the strength, that is resistance against fracture, when we are going for the density, so the parameter there, it is the density. When you are talking about density, you require a particular density of material or particular elastic modulus. Then you can choose a material from among these which has a low energy content. Next. Even some of the materials, you can see some materials, the energy is getting more very high. Why? It's because majority of these materials in construction materials are there being industrialized. They have been industrialized. There were days when all materials required for building constructions were made available in a village. Now when you see, no material is available in the village for construction of building. Everything has to come from the town or city. Even majority of the cities, they don't have the material and they have been industrialized. Industrialization of construction material has led to consumption of huge energy, especially for transportation and for the quality. For instance, transportation, it takes a lot of energy consumption. If you want steel plant, you can't find a steel plant in every town or district. You need to take at least 5 to 1,000 kilometers to get steel. You have to get it from a steel producing factory. Similarly, industrialization of construction material has increased the energy consumption. So this is the idea that we want to tell, that locally produced materials, they have low embodied energy and they consume low energy. Next. Then the other factor that we want to I want to share with you is the thermal comfort. This factor generally we engineers, we don't take into consideration, but nowadays everybody is talking about thermal comfort. We have been getting thermal comfort. In the earlier days, there used to be bigger wall thicknesses, then what we call as a bigger section, to have capacity of the section, what we call there is a building envelope, wall roof. So earlier they used to be the section of the walling element or the roofing element. Those elements should have higher thicknesses to have greater capacity to transfer the heat. And now you can't venture to have bigger thicknesses of walls and high thickness of material components. So for that, now everybody is going for RCC. Frame is only always RCC. All the partitions that we are doing are either with glass or partition, jib boards, or even 9 inches brick walls, 6 inches brick walls, and all that. So thermal comfort has become a big issue. Then The architectural inputs into thermal comfort have been that there used to be window size. There is a ratio in the code saying that the window ratio to the openings, floor area ratio to window area, then cross ventilation. Then they talk about the number of air exchanges in a building, in a room, given room. The number of air exchanges means the amount of volume of air that times that comes in and goes out in a day. So number of air exchanges, direction of the windows, those parameters were taken care earlier, but now because of the space constraint and all that, that is also can't be done. And now we have to think of other ways of meeting these things. Then we started using air conditioners, then fans and all that. Air conditioning is definitely going to add a lot of demand for energy, and also you'll be producing so much of CFLs. So it's hugely objectionable, and India is planning to reduce it. One thing I can say that India is going to spend 50% of its energy production only to cool by 2050. The total consumption of energy, 50% of the energy produced by 2050 will be used only for cooling the buildings in India. So that is the level of energy requirement for cooling the building. So there is a need for shift to avoiding the air conditioners. Then we have to go into the physics of the materials, then how we can improve the thermal comfort inside a building. There are some parameters which are dealt in the code, functional requirements of buildings. They say we have thermal performance index of material, and then we have tropical summer indexes. These are then there are some parameters which we have to consider, by which we can design a building, or we can design the building envelope. I'll limit it myself to now to envelope. Envelope is the building section. It can be a wall or it can be a roof. It's not a frame actually I'm talking about. I'm talking about a building envelope. So this comfort zone, generally this comfort zone in a building that can be attained in terms of the tropical summer index. We have the code says that if the temperature and humidity, given temperature and humidity, you will find comfort zone in a particular temperature that is between 24 degrees to 27 at relative humidity, and 26 to 31 degrees at 30% relative humidity. 30% relative humidity is somewhere like Hyderabad. 70% relative humidity is somewhere in coastal areas. So this comfort zone must be arrived at. Further, the building design should be to achieve at this comfort zone. The idea is to give an exposure to the students that there is a need of comfort zone in designing a building. Next. So this is a building, of course, we call this a building envelope. Every building material, that it will have some U value, the thermal transmittance and then thermal resistance. They depend upon the color of even the color coating outside the building, that's going to change the transmission of heat, and the heat storing capacity of the building section, and the thermal resistance offered by the material. So these things are every component has got different value. So when you select a building component, you must be thorough with these new parameters of thermal transmittance and thermal capacity. Next. Then when we design a building, we don't take into consideration how the other economical factors. That the top picture shows that of course a filler roof. It's a filler roof that we are placing, hollow core filler roof. That's done. That is industrially produced. The bottom picture shows this is a RC plank filler roof. This is also a filler roof where the bottom portion of some part of the bottom portion of the concrete is replaced by precast elements, and then concrete is poured. So when we look at when the two buildings can give the same function and the same strength, the other parameter that comes into is the employment potential. Employment protection. The industrially produced around 11% of the population depend on construction activity, and their wage, their livelihood is based on construction and building construction. So when we design a building, when we take one parameter, the one parameter that we can add to our is the employment generation. Employment generation should be one of the parameters to select a building component or select a building material or to select a building envelope. Next. Then just to design a buildings, these are the parameters, strength, safety, durability, embodied energy that we have to, every material has got some embodied energy. Then when you are designing a building, just make a list of how much energy of each building component is going to consume. The metal, how much consumes, cement, the sand, the water, the fly ash, or what the brick and all that. Then the embodied carbon or the carbon footprint. Then the envelope performance. If you are going to design a building, then the building you should design not only a frame and you forget. Always we find that all our structural engineers, they limit only to the extent of designing columns, beams and slabs. No. Now the number of elements in a building are going to be more in number than these 2-3 elements. There is going to be fenestration, there is going to be walling, there is going to be ceiling, there is going to be flooring, there are services. So all those things then all make an envelope, and we have to check the performance of the envelope. We can do that by thermal performance index. This we can calculate for every envelope. That can be done, and then you can assess at the indoor environment. Tropical summer index also you can do. Then you look at the employment generation, the life cycle cost, which material, which parameter, by replacing how much cost which material costs what, and what technology can reduce the cost, and all these things you can do. You can do by you can add some. See, if you want to design a complete building, then not everything can be done in a basket. So you have to assign some weights to each of the parameters. Then you arrive at the building index. Then you can have a building index saying that this will have so much of structural safety, then environmental and sustainable parameters, and you can make it as a green. So something like when we calculate the air pollution, we take 4 parameters into consideration: PM 2.5, PM 10. Then you take only COX, NOx. We will not take all the 30 parameters into consideration, and we arrive at one index. Similarly, for a building also, you can arrive at one index based on the number of parameters that we look at into. Maybe strength, stiffness, safety, energy, carbon footprint, then indoor environment, envelope performance, like that. Next. These are some of the different methods that these are some of the methods that you can come across. It's not limited only to this thing. Now the construction technology is moving ahead. The top one you can see is a pillar roofing, where the in the bottom of the slab, of course, in a slab in the bottom there is always a tensile, and you need only steel. You don't need any concrete below the neutral axis. So that area where you don't need the steel, the portion of concrete is a waste. So that has been replaced with some filler material. Then you have some traditional methods of doing it, the hollow bricks and all that, using steel as a concrete element. Then you have precast hollow roofing channels. The bottom one, you can see the whole building has been designed as a frame, where it's not limited only for the column and beam, but it's a whole the walling sections, tunnels. We generally design it as a tunnel, as a RCC tunnel like. Then you can see these are the precast element. Each element is designed separately, manufactured in the industry, transported and placed. Or you have the new method that you may be knowing, that the shear wall thing, where the whole concrete is poured at once, right from the slab to the foundation in a one go. Within 3 days, you can raise a floor by every 7 days. You can have one floor for every day. You have increased the speed of the construction. See, the basic principles of strength, safety remaining the same. The other parameters of indoor environment makes much difference when you go for the new materials like this. Next. There are different options that have come up. We have some composite sections also coming up now. Then like the first one is a stabilized mud. The second one is a This is produced by Kerala government of India, where the phosphogypsum seeds are panels are being produced, and Tata is already using it. The second one, the third one is a steel gauge frame we have. See, the whole building acts as a frame, thin light gauge steel we call it. It's nothing but small 1 to 2 mm thick steel anglers. The whole frame, it looks like something like a frame. Then it is cladded. The bottom one, you can see you have a regular type of column beam frame. Then the filler is used by EPS solutions. The other is also the general brick. So we have alternatives in the materials that are available in the market. We need to look into the not only 1-2 parameters of strength and safety, but all 2 other functional parameters. Next. So now there is one agency in the Ministry of Government of India, that the Building Material Technology Promotion Council, BMTPC. They have come out with some parametric study, like parameters that they have arrived at. As I said, the ISO, there is an ISO system where they have identified 36 parameters for sustainable construction. Here, what they did is they have arrived at some attributes by which the parameters can be finally selected. See, you can see the primary attributes are primary attributes, secondary attributes, and tertiary attributes. These are the attributes which we can be attached to, and preferential mandatory. See, strength, stability are mandatory, performance and core compliance is mandatory. And the preferential in these attributes, you find functional requirements. Then the functional requirements may be a design compatibility, design flexibility, restriction in the service, then thermal comfort, acoustic performance, and skilled labor, use of skilled labor, availability of equipment, construction safety, economical viability. Of course, we do. When we talk about design, the finally thing is that we have to arrive at the final cost and to compare with the available material in the market. Which one is going to cost us less, and which one is going to get it done in a faster way. So time is another factor. The finishes, the sustainability, maintenance, life cycle cost is one thing which have to be necessarily looked into while making a design. We cannot limit only to 2 parameters of strength and stability. As I said, we need to look into these. So all these parameters these are all the attributes which you have to add to your design parameters. Next. This is how we try to put some of the parameters, check some of the parameters of different types of buildings, and try to arrive at some building index, environmental building index. This is how we can say this particular building has an environmental index value of 1. This building has an environmental index of 1.2 or -6, -4. You can see the building with RCC shear wall and roofing has an environmental index of -6 compared to a recommended green building of 1. You can see a building with ordinary masonry and all that, it has an environmental index of 0.9, nearer to the green building, but the building with shear wall and roofing is -6. These are all the data which we can see, the number of attributes that you add to your design that makes your building green. Next. I can say this is a small radar, or the radar you can draw. If you go towards the more technological inputs into the building, then you will be using more metal, glass, plastic, aluminum. When you come towards the normal usage, then you will using the locally vernacular materials like stone, bamboo, timber. That reduces the energy, leaves the low footprint, carbon footprint, and it consumes more local materials. And there is a employment generation being done there. When you go to the technological towards the plastic and aluminum, when you deal with these metals of plastic, aluminum, and metals, you will be depending more on the industrially produced materials, which will have a lot of carbon footprints. Comparatively, you can see around 16 to 17 times the carbon footprint to that of a local material. Next. So this is what I wanted to add actually. So some parameters which I tried to add to the regular design for sustainable design of building. I can capsule them now that we added one thing, that is apart from the strength and safety. One thing is that we talked about energy, embodied energy of the material. Then we talked about the carbon footprint that each component of the material that leaves. Then the third part that we talked about is the thermal performance index of a building section. So when we talk of a building, then we would divide the building into building envelope and envelope containing two facades, walls, roof, flooring, and all that. Each element is to be checked for its thermal performance, and then overall indoor environment, arriving at to the comfort zone. So we talked about the comfort zone. How do you arrive at? How do you manipulate the materials required for the walling, roofing, and the building sections? Then we also discussed about the need of low consumption of material like water. Water is a very precious, and we consume a lot of water. 20% of the water that is used for curing. So materials which consume low water, either for manufacture or for curing, are necessarily to be selected now, because when we are spreading our activity to construction, huge activity, when our requirement of construction is going to be 4 by 2050, then there is huge pressure on water. There is huge pressure on the clay, huge pressure on the sand, of course. Then alternative materials come in. Then we discussed about the need of use of local materials to avoid huge transportation from the factories. Generally we target, or we aim at, or we demand for industrially produced materials because of their precision and quality control. Yes, of course, the industrially produced materials have the generally they are inbuilt quality control materials. Quality is being monitored at their level. The local material producers do not have the facility for quality control. So then what is required is to create an entrepreneurship for producing quality material at the local level. That reduces the energy burden, that reduces the carbon footprint. So these are some of the factors which I wanted to tell. And majority of the major construction activity, when you calculate the whole parameters, when you look at strength, stability, energy, embodied energy, carbon footprint, then you talk of water consumption, then you also talk of employment generation. How much employment that it can generate, the whole structure as a whole. As you make an estimate, simple estimate, you prepare an estimate after complete design, you prepare an estimate and say my building costs around 5.2 crores. Similarly, what I suggest that our engineers, that after giving not only the cost of 5.2, you also arrive at the material requirement. Then what is the energy that is going to be embodied energy that you are going to consume in that building? What is the energy that is going to be consumed in the building for maintenance? And what is the footprint that the building is leaving? And what was the water that was used for the building? So the complete auditing of the material auditing and energy auditing has to be done even for the building construction. Maybe this part of the material selection in terms of environmental perspective, or in that, of course, environmental perspective is nothing but the sustainability perspective, because we'll be consuming low now, leaving something for our future generations. So I think this will give you a small insight into the factors. I think I'll close here. I'll open up now. If you have some, we can discuss. Srinivas Garu?
Yes, sir. Yes, sir. Thank you, sir. Dear participants, please unmute yourself and ask the questions, or post your questions in the chat box. Sweta madam, please stop this screen sharing.
Okay, sir.
We can.
Good afternoon.
If somebody has got any doubt, we can see the screen also.
Respected sir, I have a small doubt, sir. Today, almost all our constructions are people are investing for the most of the economy for the Vastu Shastra.
Can I know who is speaking?
Sir?
Can you introduce yourself and then come back?
This is Dr. G.V. Satyanarayana, Professor of Civil Engineering, sir.
From GRI.
Yeah. So totally today, almost all are believe in the Vastu.
Yeah.
can take the Vastu, that will be definitely will be a defect of our greenhouses effects.
Vastu is not an element that we generally don't we speak. Vastu is actually the word, Sanskrit word used for an orientation of a building. There's an architectural part of the building. Of course, it can be a green building parameter, because parameters that we take as far as the building it mostly deals with the indoor thermal comfort or indoor air quality. These two parameters can only be achieved by a Vastu subject. One, that the wind flow shall be continuous, number of air exchanges shall be more. Generally, every architect design a building assuming that the Indian building should have at least 5 air exchanges. If your building is facing towards east and then you have a northwest, this thing, number of air exchanges may be more. That's one factor. The other factor being the light availability of the thing.
Yes, that is long
Except that nothing is there in Vastu. Vastu is only orientation of building, no way connected with the material use and our building design.
But whenever they come to, sir, they are taking the openings. They are disturbing the openings of our doors and as well as windows also. It is not a place, it is not a good place.
See, it's all belief. Vastu is not a science, let me tell you very clearly. It's only a belief.
But whenever you are taken the cross ventilation of the building.
It was one empirical formula. Yeah. See, cross ventilation is a common sense which every engineer has to follow. Because why do we go for cross ventilation? The simple concept is that number of air exchanges. Even the building code talks about the ratio of openings to the floor area.
Yes, sir.
Openings to the floor area that meets the requirement of number of air exchanges.
Yes.
For having that openings, you can orient your building in such a fashion. See, the shorter wall lengths on the south, longer wall lengths towards east. These are all very, very simple common sense that the sun will be exposed for a lower area, surface area towards the south. So it's only the sun and air that matters. And Vastu is not, it's not scientific or it's not technical. It's purely belief. It's nothing to do with our construction engineering or anything.
Okay. Most of the today in the European countries, they are replacing the aggregate itself of the clay in cement concrete also to make the green concrete.
No, see, green concrete, the idea of green is that you consume less.
Yes.
You consume less. Green concrete, bacterial concrete, we are going for stone instead of stone, crushed stone, we are going for manufactured stone, manufactured sand. These are all nothing but it's a waste products. Whatever the crusher does, that we are calling it as a manufactured stone. It's nothing but a renewable energy from a waste.
Yes, sir.
It's a replacement of material used because both the regular sand and the manufactured sand, they follow the same code. The code is same for both the things, for both the materials.
Sir, I'm Dr. Mohammad Hussain.
Sir.
I'm professor here.
Yes, sir.
Really, I appreciate your initiative, sir. And also I have seen you have academic interest also, you have many degrees. Nalsar also you have taken. Okay, sir, are you really implementing all these technologies in your state government? In Swagruha?
Of course, in government, see,
Are these only academic interest?
Yeah, why not? One thing I can tell you. See, use of locally available, if you go into even any government department, the standard specification book says that you must use locally available material and it should have the least lead. So that itself indicates that you are going to be a sustainable building. Number one. Number two, when you go for a new material, see, all the regular materials are there available in the standard schedule of rates and everywhere. When there is a new material, then there is a lot of huge involvement of industry. So government discourages involvement of industry. It is the private market which is coming out now. They are using a lot of steel, glass, rubber, plastic, aluminum. These are the 4 or 5 elements which are really high consuming, high energy materials which are being introduced into the construction. They are not actually, they don't have any structural function in the building. These materials, they add only to some architectural importance or only aesthetic importance. They have replaced aluminum because it's very ductile, it's easily operationable, it can be handled easily, lightweight. When compared to the energy, if you can go back to my presentation and see the energy inputs, the energy, embodied energy of steel and embodied energy of aluminum, it's several times higher. But now the market is such a way that people use aluminum as a common material for even for door frames and window frames. So it is a choice.
Yes, sir.
It's a
Okay,
choice.
sir.
You have a lot
Now,
of materials available. Yeah.
Yes, sir. That Indian Green Building Council code, are you taking those recommendations? Because there is also important parameter.
They
Indian
have
Green
no
Building.
code, sir. As I said, IGBC is an association. It has been not codified. So far, the government has not adapted or adapting any of the IGBC or GRIHA. We have 3 or 4 agencies which rate the building. It is something like giving a rating to the building. So there are the associations. One is supported by the government of India. The others are other associations. They have set out some parameters giving 100 marks. So if you are going to address those parameters right from the selection of the site to maintenance of your building, then you will be rated. If you are getting more than 75 marks, you are going to have gold, and if you are getting 90 marks and above, you are platinum, like that. So that's all a commercial gimmick that you can put that board on your building is a platinum rated building now, because now our Secunderabad railway station is also gold rated railway station. But that helps, that encourages people to follow green methods in design of a building. Our being a civil engineer, because majority of the faculty are here, our aim of addressing this particular factor is that there are other factors like embodied energy, carbon footprint, employment generation, water consumption. Then these factors are also to be addressed. When you check for the design, when you complete your design, you go for check for deflection, check for strength, check for shear. We take separate parameters and we check everything to be within the limit. What I am trying to put is that you check for these things also. Check every building for your energy consumption, carbon footprint, water consumption, power consumption, and maintenance. These are the parameters that we also add to it.
Yes,
We
sir.
also
I have
yeah.
Actually this WIPO, World Intellectual Property Organization.
Yeah.
So they have given Green Technology Book 2022, Green Technology Book, sir.
Yeah.
So actually all the technologies that are available to adapt to the climate change, they have given, including engineering, including building,
Yes.
component and all.
Yes.
It's really very interesting, and we can incorporate some of the suggestions. Thank you, sir. Thank you very much.
Yeah. Even government of India is also doing, is trying to compile all the technologies across the world, and it has brought out, if you can, somebody can go into the website of the Building Material Technology Promotion Council. So,
yes.
Yeah, Building Material Technology Promotion Council, BMTPC. You have a lot of, all the technologies have been compiled, and all the technologies have been reviewed to our Indian conditions. Indian conditions, and they made a recommendation. They made recommendation that which technology suits better for what category of income, whether it's a commercial building, whether it's IT building, whether it is a low-cost housing building, whether it is going to whether you are going to construct in the coastal area, dry area, it's in a desert. So it's a very good combination. But my idea is that when we talk to our students in the masters or in engineering, let them not focus only to stress and deflection. These are all other parameters which need to be included into it. These are the sustainability parameters. National Building Code has already come up with our durability parameter. It has not yet come up with the sustainability parameters, but sustainability parameter is linked with the durability parameter. In durability parameters, there is only rating. Even if you see the code, the durability parameter in the National Building Code, it talks about they define the areas, coastal zone, dry zone, and all that. So these things these are all the other parameters that can be added to your building design.
Yes. Thank you, sir.
Director, sir, good afternoon, sir.
Good afternoon, sir. Sir,
Sir, please ask the question, sir.
Sir, namaskaram andi. Na peru Janshal Narayanamurthy. I don't
Namaste.
belong to civil engineering profession, but an interesting coverage you have done in today's lecture, sir. Thank you for that. Sir, in the slides which you had shown right at the introduction stage, you have mentioned about 3/4 of the construction is yet to come.
Yes, yes.
In fact, I don't know what is the rationale behind it. Is
This
it
is a study?
why I'm asking that is already we are saying concrete jungles, and now listening to that saying in the next 50 years, another 3/4 is yet to come.
Yes,
It's
sir.
actually quite shocking, and it's quite scary actually.
Change is inevitable. Urbanization is inevitable. You can see if you look at the China, the urbanization about 20 years back was that 40%, 30% rural, 75%, 30% urban, 70% rural. Now it is within 20 years, it has shifted from 70% urban to 30% rural. And India will also have to pass through it. By 2030, 50% of the Indian population will be living in urban areas. And definitely every community, every society will have to transform into urban locality. Of course, there are areas where, see, the sustainable development goals, we have SDG 11, sustainable cities. They talk much about the intensified urban areas and extended rural areas. But urbanization is a reality. It's a reality, and we have to address it. As an engineer, our job is only to address it. We can't stop people moving. We have to address their needs. People build houses. We have to provide suitable solutions for them.
So it's not a simple, how do I say, heuristic or statistical projection. It is a rational and good calculation.
No, sir, that is a study made. If I look at, if you can go back to my slide, there is I made a reference also. There is a study made by one agency supported with the Ministry of Urban Development. This is not an ordinary. That is a study report.
Okay. Sir, another question is this, you did mention in your question answer session also about this rating called Griha, etc. Will that become a mandatory, or it will just retain, it will remain as a not ornament, as a qualification for certain types of buildings?
So far,
or will some agency will come and enforce it as such? Like, for example, you have Zakat rating for hotels.
Yes.
So users do watch that and say, where does this restaurant fall as far as the rating is concerned?
Yes, yes.
So do you feel that the buyer only will see whether does it have rating or not, or there will be some sort of an enforcement that will come in near future?
There have been efforts by these associations like the Griha and IGBC lead to make it a mandatory into the building bylaws. Basically, our all construction activities are governed by the local municipal bodies, municipalities, corporations, and the urban development authorities who give permissions. So they made so many recommendations, but it's said to be some are considered like net zero building. Now we talk about net zero. That's why the legislation came. Now it is that you may be knowing that BEE, Bureau of Energy Efficiency, they have taken 10,000 square meters as a parameter, commercial only. So our enforcement is now limited to, as far as energy consumption, our enforcement is limited to commercial. We have not gone to residential, number one. And our effort towards the building waste conservation is that we have if the building is 25,000 square meters, the township of the building 25,000 square meters, as per the, because it needs environmental clearance. There they say that zero net zero building, where the water which is coming out, the discharge that is coming out of the building has to be reused. So we have another pipeline where we have the drinking water pipeline, the wastewater pipeline. The third water pipeline is the grey water pipeline, where the utilized water, the consumed water is again reused for flushing. Already there are buildings. The government is giving some incentives for that. If you are, if it is a zero net building, like a zero wastewater building, if you certify, then they provide you 35% concession on your water bill. It is already there. It's implemented in Hyderabad by Hyderabad Metro Water Works Department. There are institutions which were trying to even reuse the bathroom water. Okay, my area of interest was only to indicate some factors which can go into the faculty so that that can be told to students.
Sir, by any chance, is there any building that can proudly announce that we have a Griha rating or something like that?
Yes, there are thousands of buildings in Hyderabad. There are hundreds of buildings in Hyderabad.
No, anything, I mean, which you can mention so that, when we talk.
Even their headquarters, IGBC headquarters, Indian Green Building Council headquarters, is the CIA building in Gachibowli, Madhapur, beside that Shilpa Raman.
I know the place. Yeah.
That building itself is a green building. You can see how the waste is, how do they degrade the waste, manage their waste, their lighting is how they manage the light, orientation of the building. You can see the building. There are hundreds of buildings. If you go to their website and they click, they have all thousands and hundreds of buildings.
No. I wanted to know specifically this Griha rating as such. Okay, sir. Fine.
Yes, you can go to CIA building. Confederation of Indian Industry Building, Madhapur, beside that Shilpa Raman.
Thank you, sir.
Yeah.
Any more questions, please?
Sir, good afternoon, sir.
Go ahead.
Yeah.
Good afternoon.
Good afternoon, sir. Myself, Lavanya from GRIT, sir.
Madam.
Sir, a small question regarding the material auditing. When you said,
yes,
is to what extent this material auditing is done, sir? It's like mixed design parameters, strength parameters, or is that related to this embodied energy? What you are mentioning about?
Yes, madam. That's what I say is that audit means the amount of inputs that are going into our building. The amount of input that is going into the building, because we are limiting, as far as our structural engineering is concerned, we are limiting ourselves only to design our building, but we are not going into the material inputs into the building. So that audit must go. When you are using, see, if I want a structure which can stand for 50 years, which is given for a given earthquake load of 5.86 Richter scale. So what inputs are going to that building? If you have an alternate metal, what inputs are going to the same other building with the same, which can withstand with the Richter scale of 8.6? So that auditing is required. It's nothing but putting down the inputs.
So who is responsible for this material auditing, sir, in general?
Engineer. Whoever makes a design, he is responsible for that.
Even for the auditing also.
No. Government will, let's forget about this. Government only contributes about 5 to 10% of the construction. The individuals construct, whether for commercial use, residential use, and all that. Of course, government have their own methods of checking by way of cost inputs and performance outputs. So even our design parameter should have that input audit and as well as output performance indicators. So performance indicators, as I said, the ISO 12,000, 21,000. There are 36 parameters which design about the sustainable building. So those, if not all, so you can choose what you can bank upon or what you are concerned to look into it. You take some parameters and then you audit. You check what are the inputs that you have made and what are the performance of your building. See, finally, the final outcome is only few things. As you said, see, instead of going for tear and wear, instead of going for bending, checking and all that, you to take concrete piece and do it under UTM, that gives water resistancy also, porosity, water resistancy, absorption, everything is covered with simple test of compression test.
Yes, sir.
Yeah. Similarly, if you take a building, then you put a small audit. The final outcome should be the thermal comfort. If you can arrive at the thermal comfort zone of attaining around 22 degrees centigrade without air conditioning, then that is the final outcome. So you have designed well. And if it can withstand a earthquake load of 5.6 on the Richter scale or something like that, whatever the wherever the zone which you are staying at. So the internal thermal comfort, strength, stability, some 3-4 final parameters we can take and arrive at the performance of the building. So what always we check is only 2 parameters. That's what I am stressing upon every time, is that it's not only the strength and stability that we check. There are other parameters also. How much of carbon footprint that you are leaving by your structure? What is the embodied energy that you are taking into your building? What is the amount of energy that is required for life cycle building, life cycle cost, or we say. The finally generally, see, a common man talks about only say finally says, sir, kitne mein banta hai? What is the cost? The common man asks for cost. So as a structural engineer, you will say how you have designed your structure, how much, whether you are able to get your parameter with the least sections. As a structural engineer, you'll be very happy if you can take care of your all loads with the least section, where you are reducing the volume of concrete and volume of steel. So material reduction is of course a sustainability parameter to meeting the same required strength.
Thank you, sir.
Thank you, ma'am.
Good afternoon, sir. This is Hemlata from JRIT.
Madam.
Actually, my question is from the last point, what you have already preferred.
Madam?
Are there any, how to avoid that? Are there any practical examples you have gone through in the designs? Are there in the Hyderabad or wherever you are there, which middle class people have done, were staying with the green
I'm not
building
audible,
concept?
madam. You can post it on my message. You can message me. I'll answer. It's
Okay,
not audible.
okay.
You're not audible, please.
Now it is okay, sir. So is it audible now?
Yes, please.
Yes, sir. Actually, my question is like the initial investment is high than the traditional building that middle class people cannot afford, I think. So how to avoid that? Are there any practical examples you have gone through which are on live that middle class people are staying with us green building concept?
But it is not the building. Green building is not that we are transporting or we are importing some material to build a green building. Green building is only a concept where you arrive at your required thermal comfort, strength,
yes,
for your required area or required volume of construction. So what material composition you want to manipulate? You have to manipulate with your materials to arrive at the required parameter. Low energy material, select low energy material.
Generally, what type of materials are used to prepare this?
I've discussed about some of the building sections, madam. If the low cost housing, we do generally we promote saying that to go for reduce the concrete in the area below the neutral axis in the slab. Reduce concrete, fill it with some inert material. That's one, and reduce the volume capacity of the section of the wall or a concrete. Reduce the non-core area, make it a hollow, reduce the volume. So reducing the volume wherever you don't need.
Is the code permits that, sir? Is the code?
Yes, code permits it. Code talks only about whether you arrive at the required checks or balances are made or not. Whether you arrive at the required strength, whether your material or whether your component is capable of taking the desired loads or desired stresses, that's the code. Material doesn't matter. Hollow, we can see nowadays you can find walling items, you get hollow bricks are there, hollow waffle roofing panels are there. It's widely practiced across the even all our software companies use now hollow core panels as roofing elements. They don't go for regular RCC slab. They are not going for monolithic RCC. They are going for precast waffle walls, roofing channels. Even walls also. Now you see everywhere you find hollow bricks. You don't
Yes,
need a solid
below the neutral axis you have prepared no, and where any key issues are there to balance that stress. That is my intention.
You can make a study if you want, because this is concrete in the below neutral axis has been replaced with inert material. Without this, you can do by coconut. People use the waste material, plastic bottles. Then the people use tiles. You do coconut. You do with paper. You do with brick. You can see, the idea is you require a minimum Z for design. So section size is required, Z is required for the moment of inertia, and anything below neutral axis is a waste, concrete. So keeping these two parameters into consideration, you can manipulate, remove the area of concrete, retain the area of steel in the tensile zone, remove the area of concrete in the tensile zone, and replace it with some other material. There are so many buildings which are constructed about 20-30 years back. We have constructed buildings, they are alive, they're able to use it, and they are safe for impact loads also. Our general 300, whatever the 300 kg per square meter, whatever the load that you are planning to design, that is, it can take, they are doing well.
So I have one last question. I have referred to Building Materials Technology Promotion Council website.
Sure.
I have referred. So there you were telling about the technologies that are available.
Yes, sir.
So is it priced publication?
They're all free publications, sir. You can download them.
Achha, you are referring to publications only, no?
Yes.
In that the technology is available.
Yes, sir. Yes, sir.
And Navariti also they are telling new construction technologies,
yes,
certificate course also they have initiated. So thank you very much, sir, for educating us. Thank you.
Any more questions, please? Sir, I think no more questions, sir.
Thank you, Srinivas.
Sir, even though you are very busy, sir, you have given us time.
Sorry,
and your valuable time.
Come in time, and I could not tell you that I was busy because I was stuck up with my secretary.
Yeah. Thank you very much, sir, for sharing your experience, and you explained very well on need of green building, environmental effects of buildings, green building rating system, parameters for design of a building, and thermal comfort. Thank you very much, sir. Thank you.
Thank you, Srinivas. Thank you very much.
Dear participants, tomorrow we have session on innovative materials and emerging technologies in building construction. So it will be taken by Dr. S. Gangaram, sir. So please be joined by same time, that is 2:15 p.m. tomorrow. Thank you, one and all. Thank you very much.
Thank you, Srinivas.
Thank you, sir. Thank you. Hemalata madam, please.